hydrogen. Till now, we were discussing the redox reaction, oxidation and reduction in terms of gaining or losing of oxygen and hydrogen respectively. Yes. But now if
Yeah.
I say the basic point is electron removal is nothing but oxidation. Okay. And
Yeah.
electron gain is nothing but reduction. Okay. So even if there is
Yes.
no oxygen and hydrogen involved, but if the atom element is gaining or losing a electron in a chemical reaction, it will be termed as reduction or oxidation respectively. Example, let's see this. Okay.
Yeah.
This is now what is happening. This is a chemical reaction, and what is happening here? This is the element of sodium. This is the element of sodium. Here it has lost this one electron. Yes, it has
Yeah.
lost this one electron, therefore it has become the cation. Can you understand this? It has become the
Yeah. Yeah. That time.
cation. Yes. Is this a chemical reaction? Yes, this is a chemical reaction.
Yes.
What type of chemical reaction is this? Can I say oxidation is
Oxidation.
taking place here? Yes,
Yeah.
oxidation. Fine. Let's talk about
Yes.
this chlorine. This is the element of chlorine plus one electron. It is giving me the anion of chlorine, that is the chloride ion. That is the chloride ion. This is a chemical reaction taking place, but what type of chemical reaction I can say? Reduction. Yes.
Reduction.
Now,
Yes.
so these are like separate oxidation reduction. If I join them, see, if I say sodium element combines with chlorine element to give me sodium chloride. Okay. Sodium chloride.
Yeah.
Now, sodium is one element, chlorine is another element. Together, it is forming sodium chloride. If you see this reaction, I think this is nothing but combination reaction. This is nothing but
Yes.
combination reaction. Yes, two or
Combination
more
reaction.
than two reactants combining together to form one product. Clear cut a combination
Yes.
reaction. But is this also any other type of reaction? Yes, this is also the redox reaction. Yes. So both
Yeah.
the reactions, two type of reactions can be seen in one reaction, and that is either we can have the combination plus the redox, we can also have the displacement plus the redox. Okay. So I hope the point is clear.
Yeah.
Okay. Now the next point here is that let's suppose what is basically happening here. You understand whenever the element loses electron, okay, loses electron, what type of charge does it gain?
Even loses connect. What do you mean charge?
Will it gain any charge if the electron is being lost? Leave element.
I
Let's
don't
talk
get
about
your
atom.
question.
Yes. Let's talk about atom. Atom is a neutral atom. Okay, initially. Now, due to some reason, the atom has to lose electrons. Atom has to lose
Yeah.
electron. Initially, it was neutral. Will it remain neutral?
No.
No. What will it gain? I mean, what charge will it attain?
Positive.
Positive. Very good. So, whenever the atom or the element, we are not talking about one atom. There are many same atoms. Therefore, we are referring to that as element. Whenever the element loses electron, what will it become? It will become the cation. Okay. Basically, it will gain,
Yeah.
attain the positive charge. Yes or no?
Yes.
And when is positive charge attained? When electrons are lost. Okay. And can I say this is nothing but oxidation?
Yes.
Yes. And can I reverse
Can I
this?
just write this?
Whenever, yeah, you can. Surely you can write this. Let's scroll it here
Yeah.
from this point, right?
Yes.
Yeah.
What is that? Na plus and then plus Le IE.
One electron. One electron.
Oh, one electron.
First, I think you should write this also if you have not written. This is important. This is the
Okay.
definition of, I mean, this is the meaning of redox reaction, oxidation and reduction in terms of electron gain or loss. Okay.
Yes. Scroll down.
Done? I'll scroll it.
Yeah.
Done, bache?
Yeah.
Should I scroll it down?
Yeah.
Now see, you can reverse this. If the element, see, whenever we are talking about the redox reaction, that is very sure we are talking about elements which are in a chemical reaction. Yes, then only they'll be showing some type of the chemical reaction. I think that should be very clear. Whenever the element will lose electron in a chemical reaction, it is undergoing oxidation. Whenever the element is losing electron in the chemical reaction, it is undergoing oxidation. Okay, and see this element
Yeah.
gains electron obviously in the chemical reaction. Okay, will it attain any charge? It will
Yes.
attain the negative charge. Yes,
Yes.
and if it is attaining the negative charge, that means it is gaining electron, the same thing, and this is nothing but reduction. Okay, you can write this. Then first bit, the very important point of here is that, let's suppose this is the element, that's it. It is not in the compound form, it is not in the any form, right? It is not undergoing any reaction. Okay, it is as it is
Yeah.
in the elemental form. If it is in the elemental form, clearly it is not even losing electrons, not even gaining electrons, because it is as it is. Atoms
Yes.
will gain or lose electron when they are bonding with something, right? Are
Yes.
you getting this? But if I'm saying the element is present as it is, so the oxidation state will be zero here. What is oxidation state or number? Nothing but that tells you oxidation number tells you the charge on the element in the compound. Example, I'll explain this, don't worry. In the compound. Example C. If I say, bache, this is a sodium atom. I think it is very clear it is not even bonding anywhere. So if it is not bonding, no gaining or losing electrons. Yes. If it is not gaining or losing electrons, it will have zero charge. Do you agree with this?
Yeah.
So the oxidation number here is zero. But if I say it is bonded to oxygen here, it is bonded to oxygen here,
Oxygen.
right? It will have some charge here. It will have some charge here, yes, and that charge is plus one. So what is the charge here? Plus one. What is the
Plus one.
oxidation number of sodium in this compound? In this compound, what is the oxidation number here?
Mm. Two.
Plus one.
Oh, plus
See,
one.
sodium is an element and it is present in this compound. Na2O is a compound, yes.
Oh. Yeah. Yeah.
Yep. I show you another example. See, um, let's take this. Okay, magnesium oxide. Magnesium is one element. It is present in the compound form, that is MgO. So if it is present in the compound form, definitely it would have bonded. And if it has bonded, it would have lost or gained the electron. And if it has lost or gained the electron, it must have attained some charge.
Yes.
And what is that charge here? Plus 2. Okay, I'll explain you
Plus
how do
two.
you get this. But this plus 2 is nothing but the oxidation number of magnesium is specifically for this compound. Yes.
Yeah.
Okay. So that is correct. And if I say the oxidation number is increasing, oxidation number is increasing.
Increasing.
Can I say the number of electrons lost is increasing? The number of electrons lost
Yes.
is increasing. Because more the positive charge, more the number of electrons lost. Like less the negative, less the positive charge, or the negative charge means what? Number of electrons lost. Yes. So if the
Yeah.
oxidation number is increasing, can I say it is oxidation?
Yeah.
And if the oxidation number is decreasing, what is it? Reduction.
Reduction.
And elemental form, that means without any bonding, it is present as it is simple, just the element or the atom. Therefore, no bonding, therefore, no charge, therefore, no oxidation number. Okay.
Yeah.
I will show you the examples so that it is clear. Let's say this zinc plus copper oxide. Okay. This is a chemical reaction. Clear? Now, if I ask you what
Yeah.
type of chemical reaction is this, I think you will say simple displacement reaction. Zinc being more reactive can displace copper here. Yes.
Yeah.
Yes, Abdul?
Yeah.
Yeah. Now, zinc is also getting oxidized.
Yes.
Copper oxide is getting reduced. Yeah. So this
Yep.
is one way of saying that it is undergoing oxidation and reduction. But can you also solve it through the oxidation number? Let's see. Here, zinc is in the elemental form. It is not in bonding with anything else. Can I say the oxidation number is zero here for zinc?
Yep.
Here, it is in bonding with oxygen. Therefore, it must have gained or lost some electron. The
Yep.
oxidation number comes out to be +2 here. For copper here, but it is in
How do
bonding
we
with
know what
oxygen.
number
Therefore,
it's going to be?
yes, I will tell you that.
Okay.
Here,
Okay.
the copper is in bonding with oxygen. Therefore, it must have gained or lost some electron. Therefore, it will have some oxidation number,
Yeah.
and it has the oxidation number as +2
Yep.
here. And here, copper is in the elemental form. That means no bonding, no
Zero.
gaining, or zero. Excellent. So now, if I see for zinc, it is going from 0 to +2. For copper, it
Yeah.
is going from +2 to 0. Yes.
Zero. Yeah.
So can I say zinc is undergoing oxidation and copper is undergoing reduction? And is it the
Reduction.
same thing happening here? Yes, it is the same thing happening here.
Yep.
Okay. Any confusion in this?
Yeah. How do we get the +2? Like, how
Yes.
we know it's a
Fine.
number?
See, although this is not really much needed, but I'll quickly explain the simplest part here. Let's say zinc is bonded to oxygen. Zinc is bonded to
Oxygen.
oxygen. Okay. Now it must be something like this. Yes.
Yeah.
One oxygen atom has a charge of -2. One oxygen atom requires a valency of -2, right? So don't you think to
Yeah.
neutralize it, zinc will have a charge of +2?
Yep.
Yep. And there was this example I wanted to discuss regarding. Yes, see, let's suppose it is CuO2, not CuO2, that would be wrong. Just a second. One example that we can have here. See this one. If I'm saying Na2O, that means one oxygen atom is bonded to two sodium atoms, bache? Yes.
Yeah.
one oxygen atom one oxygen atom will have a charge of -2. Okay, so don't
Yep.
you think -2 is being divided between two, so each of them will have a charge of +1, total +2, which neutralizes this -2. Yes.
Yeah.
So if I say Na2O, just this is a random reaction just to explain you. Okay, if let's say this happens, MgO plus sodium, I will just discuss the sodium. Here, sodium's oxidation number will be +2. Why +2? Because there are two sodium atoms. So we will add both of them, +1, +1. Okay. And here it is
Yeah.
becoming 0. Can I say it is undergoing reduction?
Yep.
I hope that is clear. See, this is not really much needed, but since one or two questions could be asked on this concept, I've explained this.
You said
Just
like,
remember,
see, there's two charge
sorry,
of Na, right? You said there's
sorry,
two charges of Na.
repeat.
You said there's two charges of Na, so one is +1 and one is +1. So
Yeah, both of
it
them
becomes
being
+2.
plus.
So for zinc,
Yeah.
there's no value it tends. How do we know it's +2?
Because zinc is only one in number. It was zinc oxide. There's just one zinc atom here, bonded to one oxygen atom.
So do we have to like use the valency of them?
Yeah. In simple words, you can say the valency of them.
Okay, okay.
Okay. Simple words. Fine. That's it. But see, you will change that based on the this thing. Let's suppose three o- three this thing three sodium atoms are there. Okay, one sodium and it is in bonding with some element which is Y. This is the compound Na3 bonded to Y. Okay, any random compound Y, any random element Y. Okay, if I have to know the oxidation number of sodium for this particular compound, see for every compound the oxidation number for the element will change. Okay, so for this particular compound, the oxidation number for sodium will be plus 3. Why? For one sodium atom it is plus 1. How many atoms are there?
3.
3. Can I say it is plus 3? Yes, it is plus. Not really much needed, but just some case. Okay.
Okay.
Any confusion? Just
No,
remember
it's
two to
okay.
three things. I'm quickly briefing the redox part. Okay. From simple to advanced
Yeah.
part. Be very careful. Redox reaction is a reaction in which simultaneously oxidation and reduction is happening in a chemical reaction. Okay. Some elements
Yeah.
are undergoing oxidation while other element in the same chemical reaction will be undergoing reduction. First one. Now, what is oxidation? The gain of oxygen, the removal of hydrogen, the losing of electrons, and very, very important, the increase in the oxidation number. That is nothing but the losing of electrons. Here, just 4 points
Yeah.
defining. Whereas in case of the reduction, what is it? Can you explain that? What is it? What is reduction? The
Reduction.
removal of oxygen, the gain of hydrogen, the gaining of electrons, and very important, the decreasing of the oxidation number. Okay,
The decrease in of the oxidation number.
yeah, decrease. If it will decrease, what is it? The reduction, right? See,
Oh, okay, okay.
are you able to recall this one?
Oh, yes, yes.
Yeah, that's it. Okay. Now, secondly, it is the element which is undergoing the oxidation or the reduction in a chemical reaction. Okay, so that if the element is present in the elemental form, its oxidation number is always zero because it's not bonding. Simple, it's not bonding. Okay, for every element, for in a different compound, the oxidation number will be different. Okay, let's suppose you are friends with three people, but with every people, your friendship will be different, right? You know three people,
Yeah.
but with each of the three people, okay, you know your bonding and your level of friendship would be different. That's the same thing here. Okay, and there could be many of them who could be friends with them. Are you getting this? That's the same example
Yeah.
here. Okay, that's it. And the element which is having a reduction in the oxidation state, or which is losing electron, is undergoing reduction. The element in which the increase of the oxidation number is taking place or addition of oxygen is undergoing oxidation.
Yeah.
Last point, we can have two or more than two types of reaction together happening in the same chemical reaction. Example, we can see the combination reaction and redox reaction, both of them in the formation of NaCl from sodium and chloride. Na plus chlorine gives us NaCl. This is nothing but a combination reaction, but this is also a redox reaction.
Reaction.
Yes, simple.
Yeah, yeah.
See, uh, Abdul, see, here sodium is in the elemental form, 0. Here chlorine is in the elemental form, 0, right? Here
Yep.
chlorine is bonded to sodium is bonded to one chlorine atom. Therefore, it will have a charge of plus 1. Only one atom of sodium is there, right? So plus 1. Chlorine is minus 1. So sodium is going from 0 to
Plus one.
plus 1. Chlorine is going from 0 to,
Chlorine is plus one.
huh?
No, no,
How
minus
can
one. Sorry.
chlorine? Minus 1. Okay. So clearly it is oxidation. Why? 0 to plus 1. Increase in the oxidation number. Yes. 0 to
Yeah.
minus 1. Decrease in the oxidation number. This is nothing but reduction. Is it clear?
Yeah. Yeah.
Any confusion? And remember the simple concept. Without bonding, that means no share of, no gaining or losing of electrons, therefore no charge. Once the element is in the bonding, therefore it must have gained or lose some electrons, therefore it must have some charge. Okay, that's it. That is why we are having the charge. If the electrons are, if the element is losing the electrons again, therefore the positive charge will increase, right? And if the
Yeah.
element is gaining electrons again, therefore the negative charge will increase. That is the simple point here. And if the negative charge is increasing, what is happening? Reduction. What is happening? Reduction.
Yeah.
So gaining
Reduction.
of electrons is reduction. That is simple. Gaining of electrons is reduction. Simple. Okay. I've drawn that flow
Yeah.
chart, so you might go through that. Any confusion for the redox reaction?
No.
No. I'm coming on to the applications of the redox, that is corrosion and the rancidity. That is corrosion and the rancidity. Okay. What is corrosion? Corrosion is a process in which any element, any metal especially, okay, is attacked by some other compounds, okay, that might be oxygen compounds or elements, okay, that might be oxygen, that might be water, that might be hydrogen disulfide, anything. But the metal is being attacked by those compounds. That is corrosion. That is corrosion. I will take the
Corrosion.
example. Rusting is a case of corrosion. Rusting and corrosion, see, rusting is a type of corrosion. You can say that. Okay. Why? See, iron is the element in rusting. Okay. Iron is the element in rusting. Yes. And it is
Yes.
getting attacked by oxygen and water. Oxygen and water. Okay. And what are we getting? Fe2O3 dot XH2O dot XH2O. Okay.
Yeah.
Fe2O3 dot XH2O. Now, if you see here, iron was in the elemental form here. Can I say the oxidation number would be 0? Yes.
Yes.
Here, iron would have gained some charge. Iron has gained the charge of plus 3. Yes. Yes. We know the valency of
Yeah.
iron here, that is plus 3. So, can I say it is getting oxidized? Yes, it is undergoing oxidation. Okay. Yes, it is undergoing oxidation. Here, it is obviously getting attacked by oxygen and water. It is undergoing oxidation to form a compound which is nothing but rust. It is nothing but rust, yes. And what's the chemical name for this? Ferric oxide. What is it? Ferric
Ferric
oxide.
oxide.
Is it clear? So here,
Yep.
metal was present in its elemental form, but then it got attacked by oxygen and moisture present in the atmosphere. Therefore, since the attack was taking place, therefore the iron has undergone oxidation to form the compound, which is nothing rust and ferric oxide. Is it okay?
Yeah.
Any problem here?
No.
Fine. Now, how can we prevent rusting? How can we prevent rusting? We can apply some grease. We can apply oil, paints. Why? Because it will help break the contact of the iron metal. Let's suppose this is the iron rod. Let's suppose this is the iron object. Okay. If we apply oil, grease, paint, whatever we have, okay, it will break the contact with the oxygen in the water. Yes, with the atmosphere. And if there is no contact with the oxygen and the water, therefore no rusting will take place. Yes, no bonding can take place. No compound formation will take place. Is it okay?
Yeah.
Fine. Now, the next thing is there is one more example, that is, let's suppose I have silver. What is this element? Silver. This is in the elemental form, that is the metallic form. Yes, it's a silver metal as of now, pure silver metal. What happens? It gets attacked by the hydrogen sulfide, hydrogen disulfide. Okay, it gets attacked
Yeah.
by hydrogen disulfide, and what does it form? See, it forms silver sulfide. It forms silver sulfide, and this silver sulfide basically compound turns the silver to black color. What does it turn to? Black color. Initially it
Black.
was the silver color, now it has changed to the black color. Okay,
Black
why
color.
has it changed to the black color? See, here the oxidation number is 0. Here the oxidation number is what?
Yeah.
Plus 2. So you can say the oxidation is taking place, and it has oxidized and it has changed the black color, and this we call as tarnishing of silver. What do we call as tarnishing of?
Silver. War machine.
Clear?
Oh. How do you spell tar
Any
machine?
problem?
T-A-R?
Sorry.
How do you spell tar machine? T-A-R?
Tarnishing. Tarnishing.
Oh, okay.
One last. Should I say the next one or should I wait?
1 minute.
Okay.
Oh, silver. This is black. Done, done. Done.
Then Abdul, the main point here is that why are we saying that oxidation is not a very good thing or reduction is not a very good thing? See, if I give you the example, please try to understand this point. This is a square, right? As of now, I'll draw a
Yeah.
better square so that it's okay with you. Okay, this is a square, fine. Now,
Yeah.
there is some composition to this. Now, if I say this is the square now, and something here has been added. Something here has been added. Is this a square now? Can I call this a square now?
Yeah.
Can I call this a square now?
No.
No, right? Why I cannot call this a square? Because it might have lost the electron, it might have gained the electron, but my initial composition has been changed. It's no longer a square. It's no longer a square. Therefore, in case of silver, it's no longer silver then. And if it's no longer silver, then no properties of silver. Okay. In case of iron, why can't we use iron after rusting? It's no longer really iron there. Okay. It has lost the properties of iron. Are you getting this? And why has
Yeah.
it lost the properties of iron? Simply because the iron element underwent oxidation. Oxidation is the loss of electrons. If something is losing something from its composition, definitely that is no longer the same thing.
Yep.
Okay. Last example here for the corrosion. All of these are examples of corrosion. Okay. The last example is for copper. Copper here is in the elemental form. Okay.
Yep.
It will react with the carbon dioxide and water present in the atmosphere and oxygen. Okay. And it
Yeah.
will form copper hydroxide dot copper carbonate. Okay. Copper hydroxide dot copper carbonate. What is this? This is a compound which will give the green color to copper vessels. You must have seen that the green coating that really appears on the copper vessels or the utensils or the objects, right? What is it? It
Yeah.
means that copper has undergone oxidation. What is it? Oxidation? Nothing but the attack, right? Oxidation is nothing but the attack. And if it is the attack, can I say
Attack. Yeah.
copper has undergone corrosion? Yes,
Yes.
corrosion and nothing but oxidation. It is here in the zero oxidation number. Here it will definitely have some this thing charge, right? Positive charge. Therefore, undergoing oxidation. Is it clear?
Yes.
I will. We will go through the NCRT so that it's more clear. See, yes, I was mute and I was speaking. Listen,
Uh-huh.
copper is present in brown color initially, pure copper, right? Which is the elemental form of copper. If we heat that, it will bond with the oxygen present in the atmosphere and it will form the cupric oxide. Yes, it will form the
Yeah.
cupric oxide. Now the color of this is black. So the copper has changed from brown color to black color. Why? Because it has oxidized. Why? Because it has undergone oxidation. It
And
has
CuO
undergone
is copper oxide, right?
Cu is
Yeah.
copper, and if you write CuO, what does it mean? Copper and oxygen. What is it? Cupric oxide. Yes, copper
Why
oxide.
don't say copper oxide?
We cannot say copper oxide. Why? Because see, I've explained you this in the bridge course. Copper is present in two oxidation, two valencies, plus one, plus two. If copper is
Yeah.
present in the plus one state, it is called as cuprous. If copper is present in plus two state, it is called as cupric. And if you see here, copper is present in the plus two state. See, Why? It is bonded to one oxygen atom. It is -2. It will have to be +2. Okay. Therefore, what do we get?
Yeah.
Copper is in the +2 state. What will we call this? Cupric oxide.
Yep.
Is it clear?
Yeah.
Yeah. So see, it has undergone oxidation from brown to black color. Clearly, it has undergone oxidation to form copper oxide, cupric oxide from elemental copper.
Yeah.
See, heat a china dish containing 1 gram copper powder. What do you observe? We get a black surface. Why do we get the black surface? Because of the
Because it has CO.
hello, am
It
I
was
audible?
yeah, because of the compound cupric oxide, it
Yes.
was
It has
precipitated.
undergone oxidation. If it has undergone oxidation, it has formed cupric oxide and which is forming giving the black color. Okay. This
Yeah.
is because oxygen is added to copper and copper oxide is formed. That's it. Simple. Okay. See,
Yep.
if hydrogen gas is placed over this heated material CuO, the black coating on the surface turns brown. Why? See here again, copper will undergo reduction, and if it undergoes reduction, it will again form the copper metal here, element here. Again, we will get the
Yeah.
brown color. So this is important. This is important. This might be asked, how can we get back the the elemental form of copper again from the cupric oxide? So this is how you will get it. You will react it with hydrogen, and hydrogen will act as a reducing agent, and therefore copper will be reduced to copper from cupric oxide. Okay,
Yeah.
fine. This I've already explained. There should be no confusion in this. Such reactions are called oxidation reduction or redox reaction. One reactant gets oxidized while the other gets reduced during the reaction. See, Abdul, go through these examples. Any problem in these examples? Hmm.
That
Go through these
application.
examples, especially the
So we have
MnO2.
MnO2 plus 4 HCl MnCl 2H2O plus Cl. Why 2H2O?
That is a balancing part, bache. Here we have 4H,
Okay,
right?
okay. Yeah, yeah.
Hmm.
Yeah, no doubt.
You know, can you tell me what is getting oxidized and what is getting reduced in this second equation?
Um,
Hmm.
Mn is
Mm-hmm. Go through it. It's important.
yeah. Oh, hydrogen. Now, oxygen. So
Hmm.
MnO is
Mm-hmm.
oxygen, sorry, oxidation,
Mn.
and
Mm-hmm.
HCl is reduction.
Reduction. Okay. You will go through this. I'm giving you this in the homework. I will be discussing this one in the next class. I want to discuss this with you, but try this at your at like by yourself at home also. Okay. This is
Yeah,
important. Note down your answer right now and see when you're doing it properly. Is that the same answer that you're getting then also? Okay. Please try to do this. We will discuss this in the
yeah.
next class for sure. The first. Fine. So that's it. You will go through this again. Now, see corrosion. What do you have you observed the effects of oxidation in reaction in the everyday life? What is corrosion? Other
Yeah.
metals also get. When a metal is attacked by substances
Transitions.
around it, such as moisture and acids, it is said to corrode, and this process is called as corrosion. The black coating on silver and green coating on copper are other examples of corrosion. One is nothing but rusting. Okay, one is nothing and rusting. Okay. Now, if I ask you, the you must have heard of this. You know, the Taj Mahal getting yellow because of the effect of the acid
Yeah,
rain.
yeah.
Is that corrosion?
Yes.
And if that is corrosion, is that oxidation? Yes, that is oxidation. And if oxidation is happening, we know clearly the composition is changing. It is getting disrupted, right? So the effects, the properties will be lost. And we see that the color of the Taj Mahal is changing to yellow from white because of the oxidation, and that is nothing but corrosion. Is it understood?
Mm, yep.
Corrosion causes damage to car bodies, bridges, iron railings, ships, and to all objects made of metal, especially those of iron. Corrosion of iron is a serious problem. Fine. That's it. Rancidity. Now see, Abdul, here they have just mentioned the this thing coating on copper, green coating on copper, and a black coating on silver. I have already told you what is the compound due to which the coating is happening. What silver? What is it? Silver sulfide. Yes, it is the silver sulfide which is giving the black coating to silver when once it is corroded. Okay, and for copper it is copper hydroxide dot copper carbonate. Okay, this is the compound which is giving the green color to copper when it is corroded. Please note this down if you have not noticed this down. Okay, fine.
What I have to note
Now
down?
coming to rancid. Yeah, are you writing this down?
Yeah.
Yeah, done.
Yeah.
The last topic of this that is rancidity. Rancidity is also nothing but the effect of oxidation. Okay, in day-to-day life. See, rancidity is oxidation of fats or oils. Of fats or oils. That's it. Corrosion is nothing but the oxidation of metals or other objects. Yes. Specific oxidation of fats and oils is nothing but rancidity. Okay. What happens? Let's suppose this is the particular composition of a fat or an oil initial. Okay. If it loses electrons
Yes.
from all of these, don't you think the composition changes? It is not, it is no more the oil that we were supposed to use. It has changed. It has become harmful. Why? Because we cannot eat everything around us. We are eating things of a specific composition. If the composition has changed, this is harmful. Are you getting this?
Yeah.
And if it has lost the electrons, don't you think it is undergoing oxidation?
Yes.
Yes. Let's suppose, let's suppose we have the oil. Okay, we have the oil in the this thing, the vessel or the container, whatever we have. Okay, and we keep on burning it. Once we burnt it, that's fine. Again, we heated it. That's fine. Third, fourth, fifth, sixth times we are heating it. Don't you think whenever we are heating it, it is reacting with the oxygen in the atmosphere? Yes,
Yeah.
and it is continuously undergoing oxidation. Why? Because it is reacting with the oxygen present in the atmosphere. So that is why it is said we should not use the same oil after twice or thrice use. Okay. That is why it is
Yeah.
said that. Okay. Now see, how can we prevent that? How can we prevent the oxidation? And if oxidation has happened, it's the food material has has been wasted. It's destroyed. It's toxic now. Okay. And that is why it is said that we cannot use the food, we should not eat the food once it's kept in the outside for a long period of time, because it will react with the oxygen present in the atmosphere. It will undergo oxidation, and that is the problem. That is the problem. Okay, so how can we solve this problem? How can we protect this? The best thing is that we should use something which is antioxidant. Yes. What is antioxidant? Products or compounds, rather compounds which prevent oxidation, which prevent oxidation.
Yeah.
Yes. So example, Acha, why are we specifically saying oxidation of fats and oils?
Mm,
Almost in each and everything that we eat, fats and oils are present, and that will undergo
yeah.
oxidation really quickly. And that is why the first thing which is undergoing oxidation is fats and oils in a toxic manner. Okay, so everything that you are eating in a packaged form is undergoing oxidation once you are opening it. That is why it is said to consume it as soon as possible. Okay. So if we
Yes.
fill the nitrogen in the packets, in the packaged food, nitrogen will not allow for the contact between the food particle that is having fat or oil with the oxygen molecule, right? So if there's no contact between the particle, food particle and the oxygen, no oxidation will happen. Therefore, the food particle is safe. Okay. Is it clear? Second, it is very
Yeah.
obvious that we should keep the food in the airtight container. What will that do? If we keep the food in the airtight container, the oxygen will not really, enter in the container, therefore not really react with the food. Okay, so therefore acidity could be prevented. The third thing is that it is often said that keep the food or specific packaged food in dark, areas, as in not in much light. Why? See, more the light, more the reaction can take place because more is the energy. Therefore, more oxidation can take place. If the energy is less, might be the oxidation process will slow down. So it might not take that fast. Okay. Is it okay, bache?
Yeah.
We will go through this. When fats and oils are oxidized, they become rancid and their smell and taste change. Same. If the composition changes, the taste, the smell, the properties will change. Substances which prevent oxidation are called as antioxidants. This is very much asked in the question. Okay. Are added to foods containing fats and oil. Keeping food in airtight container helps to slow down oxidation. Chips manufacturers
Yeah.
usually flush bags of chips with gas such as nitrogen to prevent the chips from getting oxidized. They have put a question mark. I have explained this. If you want to write this, you can write it that nitrogen prevents the contact of oxygen with the food particles or the food molecules. Okay, that is why no oxidation.
Yeah.
Is it okay?
Yes, ma'am.
Any problem in this?
No.
No. Go through the questions quickly. Question one.
Where does the color of copper
Hmm.
sulfate solution change when an RNA is depleted?
Hmm.
Hmm.
What are the two reactants here? Copper sulfate solution. How will I write it? Copper sulfate solution of the aqueous form, right?
Yes.
Plus iron nail. So iron is there, right? Now, what? Just by looking at the reactants, Samad, not Samad, Abdul, you should know what reaction is happening here
Yeah.
and what type of reaction is taking place here.
Chemical.
It's very
Uh,
obvious. Chemical reaction will take place. What type of chemical reaction?
um. Redox.
Redox can happen almost, will be happening in almost every reaction. What other reaction is
Yeah.
happening here?
Hmm.
I told you if one reactant is present in the elemental form or the simple form, that is metallic form or the elemental form, and the other reactant is present in the salt solution form. Copper sulfate is a
Displacement
salt.
reaction.
Yes, displacement. The
Yeah.
element, if it is more reactive, then the element present in the salt solution, it will displace the element from its own salt solution. We will get here as
Yes.
FeSO4 aqueous plus copper in the solid form. Yes.
Yep.
Therefore, the color of this ferrous sulfate solution is green. Is
Yeah.
green. Therefore, the color changes. Okay. Is it clear?
Yes, ma'am.
Fine. Question three.
Identify the substances that are oxidized and substances that are reduced in the following reactions.
Hmm.
F4NaS plus O2 equals to O2NaOS. Identify the substances that are oxidized and the substances that are released. 4Na plus O2. So first one is oxidation, right?
They are saying it's a redox reaction, and in the reaction, we will have to know what substance is undergoing oxidation or reduction.
First, yeah, the first one is oxidation because it's gaining oxygen.
No reduction? No reduction in the first part?
So electrons removal.
Yes. See, sodium is very clear it is undergoing oxidation. Yes.
Yeah,
O2 is getting reduced. Why? See, O2 here is in the O2 form, which is zero oxidation state number. Yes. If it is
yeah,
present in Na2O, it is in the minus 2. What is 0 to minus 2? What is it?
plus two. Oh, reduction.
Reduction. Yes or no?
Oh, so it's not oxidation.
It's both redox. It's oxidation and
Oh,
reduction.
okay.
Okay. And also, if they have given the question, you could have just used this. I mean, no problem. But just a hint from the question. that they are asking in the same reaction which is undergoing oxidation and which is undergoing reduction, right? So there must be some substance which is undergoing reaction, I mean reduction, and there must be some substance which is undergoing oxidation. Okay. The
Yep.
second part, go through the second part. Already we have discussed this.
CO plus Hg equals to CuS plus H2O. CuO. So
Abdul, it is
Cu
very simple,
is
direct points.
reduction
Yeah.
reaction and H2 is oxidation reaction.
So CuO is getting reduced from CuO to Cu, right?
Yeah, and H hydrogen is getting oxidation because it's gaining oxygen.
Yes, from H2 to,
H2O.
yes. This is very important to write, okay?
Yeah, okay.
That's it. Should I, discuss these questions right now? Will you practice them by yourself? Whatever is your call, we will do that.
We can practice now.
Right now, I can practice
Yeah,
this
yeah.
with you. Fine. The statements about the reaction below are incorrect. Good question.
Yeah, it's getting reduced.
You just you
Carbon
just
dioxide
leave these
is
questions as of
getting.
now. Okay, leave these options. Just see this reaction and tell me what is happening in this reaction.
Lead is getting reduced, and
Mm-hmm.
copper
From
is getting from what do you mean from?
from PbO2.
Like that lead.
Mm. From
And
lead
copper
oxide
is
to lead
getting
metal. Okay. Second,
and
carbon
copper
is
is getting
getting.
oxidation. Oh, carbon, sorry.
Mm.
Carbon is getting oxidized. So it's
From carbon to
carbon to
carbon
CO2.
dioxide. Okay. Now that is
Yeah.
what we have. Therefore, this is the reducing agent. This is the oxidizing agent. Okay. Let's see what is the option saying. Lead is getting reduced. Correct. The first option is correct. Yes. Carbon
Yeah.
dioxide is getting oxidized. Wrong.
Yeah.
Carbon is getting oxidized. Correct. Lead oxide is getting reduced. Correct. Yes. Which one is
Yeah.
correct?
Incorrect. B.
The option is A, B, A, C, A, B, C. Lead is getting reduced. Lead is not getting reduced. It is the lead oxide which is getting reduced. So the first option is also incorrect. Therefore, A and B are incorrect. Okay.
Oh, yeah, yeah. Okay.
Right. Question two. The second question.
The above reaction is an example of
Just by looking at the reactants, you will tell me, not at the options.
Fe2O3 plus 2A is equals to Al2O3 plus 2Fe. Hmm. Combination reaction?
Huh? No.
No, no, not combination.
Combination, just one product. Be mindful of that. But since this is
Double displacement
displacement, right?
reaction?
Yes, excellent. Third one.
What happens when dilute hydrochloric acid is added to iron filling? Stick the correct answer. Dilute hydrochloric acid. Um, Iron fillings. Option A.
A. See what is happening here.
Oh
We
yeah,
have iron, that is iron filling simply means iron. Okay. HCl. Okay. Dilute hydrochloric acid. The iron will displace hydrogen here and will bond with FeCl. Okay. Plus hydrogen gas
yeah,
will be formed. Okay. Simple. So what is formed? Hydrogen gas and iron chloride are produced. Here.
yeah.
The next one. A fourth one, you can do that. Fifth one. You can also do this one. Try to do this one. Okay. I'll give this in homework. And then you can try this. Okay. Inshallah, in the next class, we will be discussing this. Okay.
Okay.
Any other objective question that we have here? So all of them is based on balancing. You should try to balance all of them. This
Yeah.
ninth one. Quickly tell me the answer.
What does one mean by exothermic and endothermic reaction? Give examples. Exothermic Wait,
Exo
I
means
didn't get.
out, endo means in, thermic means heat
Oh
energy.
yeah, this
Simple.
one.
Hmm.
Yeah, yeah,
So any reaction in which the net energy supplied is greater is called as the exothermic reaction. Any reaction in which not no sorry, any reaction in which the net energy released is greater, okay, is the
yeah,
exothermic reaction. Any reaction in which the net energy supplied is greater is the endothermic reaction. Simple. Okay.
yeah.
Why is respiration considered an exothermic reaction? Very, very simple. You will have to answer this correctly.
Why is the
What is happening
respiration?
in respiration?
Because no, sorry. It releases energy
Yes.
in the
What is the purpose
surroundings.
of respiration? To produce energy in the body, right? And if it is
Yeah,
producing energy, that means it is very clear that the net energy released is greater than every other energy in the reaction. Therefore, it is an
yeah,
exothermic reaction. Hmm.
yep.
Question 11th.
Why are decomposition reaction called the opposite of combination reaction? Write equation for these reactions.
Just tell me why is it opposite to that?
Because in combination it's combining and
Mhm.
in
Two or more than
decomposition.
two are combining to form one product. Yes.
Yeah,
Whereas in case of decomposition, one large compound is breaking down into simpler components, that is the elements, right? More than two
yeah,
elements. So one reactant
yep,
in the decomposition reaction and more than two products in the decomposition reaction. Whereas in case of
yes,
combination reaction, one product and more than two reactants. Clear?
yeah, okay.
That's it. We'll continue this inshallah in the next class. Just few points.